Good evening. Now we'll be studying electromagnetism. Um, is in most school it is called Physics 102. So electromagnetism by Comrade is a series, and the first aspect of electromagnetism is actually electrostatics, meaning we want to understand what electrostatics is. And this is all what we'll study this and some of the examples as well. Now let's start with the first one, electrostatics. From the word electro and statics, electro means electron, statics means at rest. Are you saying it? So if you combine them, electrostatics is just that aspect of physics that deals with the interaction of charges at rest. Meaning, electrostatics is trying to tell you the behavior of charges when they are at rest. So please do not forget the branch or the aspect of physics that deals with the interaction or behavior of charges at rest is called electrostatics. Now, you must understand that there are two kinds of charge. There is the positive charge and there is the negative charge. So we have the positive charge and we have the negative charge. But please, and please, both the positive and the negative, both as a result of the electron. Is that clear? Don't say because positive is positive, it is proton that is causing it. Negative, it is electron. No. Both the positive and the negative, meaning charge itself, is charges are created as a result of the electron. When there is deficiency in electron in a material, you have positive charge. Why when there is excess or surplus electron, you have what? Negative charge. So when a material loses electron, chemistry we say that atom become positive charge. While when an atom gains electron, it becomes what? Negative charge. So positive and negative both as a result of the word electron. Deficiency in electron cause positive charge. Surplus or excess electron cause what? Negative charge. Now, there's the basic law in electrostatics, and this one we are familiar with it, which is that what? Like charges do what? Repel, and unlike charge what? Attract. And you must understand that charges can be produced in three ways. The first one we have by friction. The second one we have by contact. And the third one we have by what? Induction. So the three ways in which charges can be produced, there is friction, there is contact, and there is induction. What is charge by friction? When a material is made to rub on another material, you are charged by what? Friction. Are you seeing it? So charging by friction is as a result of one material rubbing over another material. And the basic example is when an ebonite rod is rubbed with 4. The ebonite rod acquire a negative charge and the 4 acquire a positive charge. Why? Because when you rub two materials over each other, there will be a transfer of charge between the surfaces. Are you getting it? The material that will lose electron will become what? Positive. Why? That one that will gain electron will become what? Negative. That's charging by friction. Charging by contact. From the word contact, you all know that contact is actually when two bodies are in contact with each other. There's not a transfer of charge from one body to another. Induction. So charging by induction is basically you want to charge a body by another body without actual contact. That's charging by induction. Meaning you want to produce charge in another body but without actual what? Contact. That is charging by induction. And there are basically 4 steps in charging by induction. You get. So what you must understand up to this point is that, number one, the branch of physics that study or that deals with the interaction of charges at rest is called electrostatics. Is that clear? Two kinds of charge. There are 2 kinds of charge, which are the positive charge and the negative charge. And when there is deficiency in electron in a material, you have what? Positive charge. Why? When there is excess electron in a material, you have what? Negative charge. The basic law of electrostatics states that like charge they do what? Repel, and unlike charge they do what? Attract. While production of charge, charge can be produced basically in three ways, which is by contact, by friction, and by induction. The production of charge in another body without actual contact is charging by induction. And to measure and detect small positive charge, you use your what? Electroscope. So the instrument that is used to detect or measure small positive charge is called the word electroscope. Don't forget. And you cannot study charge without looking at the structure of the atom. We know the atom by Rutherford, right? Rutherford model of atom that states that the atom consists of a nucleus. Is it not true? So I have the nucleus, which is positive charge. That inside the nucleus there is the word proton and there is the word neutron. So the nucleus contains both the protons and the neutrons, and I have electron revolving around. You get it? This model of atom is called the Rutherford model of atom. Now, the next one is we now have the fundamental principles in charge. When studying electrostatics, there are two principles you must keep in mind. The first one is principle of charge conservation. And the second one is principle of charge quantization. So there is charge conservation and there is charge quantization. Now, what's conservation of charge? Conservation of charge is just telling you that in charging a body, charge before reaction should be equal to charge after reaction, or rather, the algebraic sum of the charge, of the total charge in an isolated system must be zero. That's conservation of charge. So charge can neither be created nor destroyed, right? Or the algebraic sum of the total charge in an isolated system must be what? Zero. While charge quantization is trying to tell you that the total charge in a body Q is equal to the integer multiple of the charge of the electron. So the quantization of charge is telling you that any charge that you see in a body, they are integer multiple of the charge of the word electron. And where this Q represents your total charge, this N, we do call it the charge quantum number, or sometimes you can call it the number of electron. So N is either called charge quantum number or number of electron, while E is called the charge of the electron. And you must know that the charge of the electron is a constant value, 1.602 times 10 raised to power minus 19 coulombs. Charge is measured in what? Coulombs. So please, two principles you must keep in mind: the conservation of charge and the quantization of charge. In conserving charge, before and after is the same. While in quantizing charge, you must understand that Q is equals to NE, meaning the total charge in a body Q is equal to the integer multiple of the charge of the electron. Please note that this N must be a whole number. Are you getting it? N must be whole number, meaning charge exists as whole number multiples of the word electron. So you must keep this formula in mind. Now the next one is, now you must now understand what is called types of materials. Yeah, there are types of material. So types of material. Now, basically, there are three types of material. We have the conductors, we have the insulators, and we have the semiconductors. So there's a conductor, there is an insulator, and there's a semiconductor. What are conductors? We all know conductors, right? Materials that allow electricity or charge to flow through them are called conductors. Examples of conductor: we have metals, we have the human body, What about insulator? Material that do not allow electricity to pass through them, right? Example are plastic, wood, rubber, etc. What about semiconductor? Material that have conductivity between that of a good conductor and that of a good insulator. It means semiconductor is between a good conductor and good insulator. And examples of semiconductor, we have the germanium, we have the silicon, and etc. So these are types of material based on the allowance or based on how they allow charge to pass through them. There is conductor, there is insulator, there is semiconductors. So the next one is now Coulomb's law, which is very, very important. Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charge, and the force is inversely proportional to the square of their distance. Now, because of this, we can say that Coulomb's law is an inverse square law. It means that the force, as the distance increase, the force decrease. That's the meaning of this. As smart science students, we can get a formula that relates force and distance. How do you remove variation sign? Introduce a constant k, right? You make k subject, you have f r squared. Then your formula becomes f1 r1 squared is equals to f2 r2 squared. Are you seeing it? Now, so put this formula in mind. It is used to compare between force and distance. Now, if we combine these two formula, we are getting f is equals to f is proportional to q1 q2 over r squared. So to remove variation sign, we introduce a constant, and our constant is called the electrostatics constant. So this is what is called Coulomb's law, that F is equals to K Q1 Q2 over R squared. So now, there's something we must understand in Coulomb's law, which is the behavior of this K. Now this is it. This K, the exact formula for K is 1 over 4 pi E. Where this E is known as the permittivity of the medium. So take note, E is known as the permittivity of the medium. Now, if the medium in which the charge is interacting, it means if the medium of interaction of the charge is air, or let's just say free space, or we can call it empty space, or we can call it a vacuum, anyone you want to call it. So free space, empty space, or vacuum. Then we have E naught. If the medium of interaction is free space, empty space, or vacuum, we call it E naught. And E naught is a constant value, which is 8.85 times 10 raised to the power minus 12 farad per meters. That's E naught. Then if it is E naught is this, if we replace E naught here, this K becomes what? K naught. And K naught value is 9 times 10 raised to the power 9 Newton meter square per Coulomb square. So if the medium of interaction of the two of the charges is in air, free space, empty space, or vacuum, E becomes E naught, K becomes K naught. And these are constant value. It means that if the charges are interacting in air, your formula F or for Coulomb's law becomes K naught. Are you seeing it? Then Q1 Q2 over R squared, where this K naught is a constant value of 9 times 10 raised to power 9. Now, what about if the medium of interaction is not air, meaning the charges are not interacting in air? So please take note, if the charges are not interacting in air or in free space, meaning they are in any medium now. Let's say the charges are in any medium. You now have to define what is called the relative permittivity. So if the interaction of the charges are in any other medium or aside from air, then I have relative permittivity, which is called permittivity in the medium over permittivity in free space. It means that your relative permittivity ER is permittivity in the medium over permittivity in free space. And if that is true, it means that if I make this E subject of formula, E becomes ER E naught. This formula I should not forget that if the charges are interacting in any other medium aside from air, E becomes ER E naught. Now, if I come back to this formula for K, wherein K is 1 over 4 pi E. Remember, E becomes what now? ER E naught, because the medium of interaction is no longer air or free space. So K becomes 1 over 4 pi. So instead of E, I replace it with E naught ER or ER E naught. Anyone? We can write this like this: 1 over 4 pi E naught times 1 over ER. It's saying the same thing. 1 times 1 will give you 1. This time will give you this back. Now, this term is also what is called what? K naught. It means K becomes K naught over ER. What is the implication? The implication is that if the charges are interacting in a medium that is not free space or that is not air, then F becomes K naught over ER Q1 Q2 over R squared. So you must have in mind that there are two formulas. The first one is F is equal to K naught Q1 Q2 over R squared. You use this when the interaction is in air, free space, empty space, or vacuum. Is that clear? The second one is this. You use this if the interaction is any other what? Medium. How do you know that there is another medium when you are given what? The relative what? Permittivity. Now, if a question do not indicate the medium of interaction, you assume it to be what? Air. Is that clear? So I have this for Coulomb's law. If the medium of interaction is air, I have this for Coulomb's law. If the medium of interaction is in any other medium other than what? Air. So this is what we call Coulomb's law. But you must understand that force is a vector quantity, meaning force is a vector quantity, meaning to specify a vector completely, you need both the magnitude and the direction. This formula will give you magnitude, but you must mind you, when applying this formula, the sign of the charge will not enter into the formula, meaning if it's plus 10 coulombs, you ignore the plus. If it's minus 20 coulomb, you ignore the minus. Exactly. The plus and the minus is telling you if the charge is like charge or unlike charge. And how do you get the direction? Please do not forget, like charge they do what? Like charge they do what? They repel. Unlike charge they do what? They attract. Is that clear? That is what you must understand. So this is Coulomb's law. And you must understand, when there is more than one charge interacting with each other, you take them individually, which is called the principle of superimposition of charge. Meaning, when more than one charge is acting on another charge, you take them individually. Then you now do what is called vector addition. So you must also understand vector addition. Now let's take our examples. So identical coin separated by distance 2.5 meters. So you have two coins, they are identical and they are separated by the distance. So let's start listing our parameters. R is 2.5 meters. That's the distance. In a large vast liquid, now notice the charges are not interacting in free space. They are interacting in a medium, a liquid. Don't forget. So let's continue. Are carrying identical charges. Don't forget again, the charges are identical. It means that Q1 and Q2, they are what? The same. Exactly. So they are identical charges. Q1 is equals to Q2. They're identical. As a dielectric constant, dielectric constant is the same thing as relative permittivity. So you are giving what? ER to be 92. And as I calculate the magnitude of each charge, meaning you are calculating Q1 and Q2, and do not forget Q1 and Q2, they are what? The same. Is that clear? So calculate the magnitude of this charge if the repulsive electrostatic force is 40 Newton. So F is equals to 40 Newton. According to Coulomb's law, if the medium of interaction is not air, remember, how do you know that the interacting medium is not air? Because of the presence of what? Dielectric constant or relative permittivity. Or you were told in the question, a large vast what? Liquid. So because you now know that the medium of interaction of the charge is not air, your formula becomes what? F is equals to K, Q1, Q2, this is K naught ER, right, over R squared. Are you saying it? Now, do not forget Q1 and Q2 are the same. So it means this two becomes what? Q squared. So I have F is equals to K naught Q squared over R squared. I want to make Q subject of formula. Sorry, there's ER. I want to make Q subject of formula. So I'll just I want to make Q subject. So if I make Q subject, I will have what? Q is equals to root FER R square over K naught. So then I have make Q subject, then I will substitute what? My parameters here, which is that Q is equals to square root. What is F? F is what? 40 times what is ER? ER is 92 times what is R? R is 2.5 squared over what is K? K is 9 times 10 raised to power 9. So my Q becomes 1.599 times 10 raised to power minus 3 coulombs. So that is my Q. See it? Now let's continue. The next question says, find the number of electron on this charge. Now I want to look for a number of electron. Hope you have not forgotten that Q is equals to Ne. Now the total charge in a body Q is equals to the what? Integer multiple of charge of the electron. Now what is your Q? No, you are looking for N. If I make N subject, N becomes what? Q over E. Wherein N is your Q is what? 1.599 times 10 raised to power minus 3 over E is 1.602 times 10 raised to power minus 19. So if you press your calculator, N should be giving you 9.99 times 10 raised to power 15 electrons. So that is actually the first example. Or you can approximate this and get N is equal to 1.0 times 10 raised to power 16 electrons. So anyone you want to use. So what you must not forget is that Coulomb's law, when the medium of interaction is not air, you use this formula. While when the medium of interaction is air, you remove the word ER. So that's what you must remember for the first example. Second example, 2-point charges are located as shown above. So this is a charge, this is a charge. Now we are told to find the electrostatic force exerted on the other in terms of the coordinate system. Now look at something. There is a charge here and there is a charge here, right? Notice both charge are positively charged. What will happen? Will it be an attractive force or a repulsive force? Definitely to be what? Repulsive. Why? Because they are what? Like charge. And from the basic law of electrostatics, like charge do what? Repel. Unlike charge what? Attract. So these two forces will repel each other. So I have one like this. I have what? One like this. Now, how do I get the magnitude of the force of repulsion? According to Coulomb's law, I know that F is equals to K, Q1, Q2 over R square, right? Now, I know Q1, I know Q2, I know K. The issue, we don't know the distance between these two charges. So if I want to get the distance between these two charges, which is R, if I look at this is looking like a right angle triangle, right? Wherein I have something like this. Here is 100 centimeter, here is 75, and here is R. And we can get R using Pythagoras theorem. So according to Pythagoras theorem, R is equals to the square root of 100 square plus 75 square. Then R, when you press your calculator, you should be getting 125 centimeter. Are you seeing it? Now you have gotten the distance between the two charges. Next is let's now get our force. Our force F is equals to K, 9 times 10 raised to power 9. Q1 is 2 times 10 raised to power minus 6. Don't forget it is microcoulomb. So micro means times 10 raised to power minus 6. Times Q2 is 3 times 10 raised to power minus 6 over the distance. Remember, the distance must be in meters. So if you convert centimeter to meter, you divide by 100, you should be getting 1.25 meters. So I have 1.25 meters squared. So if I press my calculator, I should be having, I think, 0.03456 Newton. So that is the force. So the force that both of them will exert on each other will be what? This value. But where there is now a slight issue is because we want that force in coordinate what? System. That is where we now have a slight issue. So to represent force in coordinate system, you must understand the concept of vectors. Meaning, and we are asked to represent each of the forces in coordinate system. Now this is it. Let's take the force on this part. Now focus on this 2 microcoulomb. You should be seeing, for the 2 microcoulomb, you should be seeing something like this. Y-axis, X-axis, and the force F. Right? On this part. Is it not true? So this is what you should be seeing. Now, you can resolve force into 2 components, which is the I, which is X-axis. You know, I component is called X-axis. And the J, which is called what? Y component. Y component is called J. X component is called what? I. Now, how do you resolve this force? The force F is equal to. Now, what is the force? What's your value for force? 0.03456. You now put bracket. I want to do for the horizontal. For the horizontal, you will now say, what is the movement in the horizontal? The movement is what? 100. So I have 100 over what is the total as a result of these two. The total is what? 125. Then I. You seen it? But to resolve force, we know that to resolve force is actually F is equal to F sine theta or F cos theta. You use that one if there is theta. Now look at, there is nothing like angle here. So trying to calculate angle, then doing some geometry will make it kind of complicated. So you can use this method that the force bracket the movement in the horizontal 100 over the resultant between the two. So definitely for vertical, you should have what? The force, right? Bracket the movement in the vertical, yes. 75 over the total 125, then J. You see it? Now this is it. Force bracket the movement in the horizontal 100 over the total plus force bracket the movement in vertical over the total. You get it? Do not forget, force is a vector quantity. It has both magnitude and direction, and the direction is basically in plus and minus. You use plus and minus to represent the direction. Now look at something. If you look at this, hope you have not forgotten your Cartesian plane. Where here you have plus y plus x minus y. Notice how this force is in this place, in the Cartesian plane, right? So in this place, the horizontal for it is what? Negative. So you put minus for horizontal. And the vertical is positive. So you put plus for vertical. So make sure that when you are resolving force, after you have done your magnitude, you must put the correct what direction. And most of the time, to get the correct direction, just use your Cartesian plane. Notice where this force is acting. It's acting somewhere here. So plus y, it means the vertical will be plus, and the horizontal will be what? Minus. You see it? Now, so if I press my calculator, my force F should be minus 0.0277 I plus 0.0207 J. That's for the 2 Newton. Now, similarly, we will do exactly the same thing for the 3 Newton. Follow exactly the same step. Watch. For 3 microcoulombs, right? How is this force? How is this force behaving there? Something like this, right? And I have the force F. Is that not true? So F, how do you resolve? The force, 0.03456 bracket, the movement in horizontal 100 over the total 125 I plus the force again bracket the movement in the vertical 75 over the total 125. Do not forget, force will have magnitude and direction. And if you notice, this part is somewhere here. Is it not true? So if you notice, the horizontal for that one will be what? Positive. And the vertical will be what? Negative. Please, are you seeing it? Make sure that force has magnitude, or vector that have magnitude and what? Direction. So if I resolve this, I should be getting exactly the same value but opposite direction, which is 0.0277 I minus 0.0207 J. So J, yeah. So that is for the 3 and for the 2 Newton. So that is how to do this. It is not something that is complicated. It's just that we have this. Is that clear? These are the same charge, which are like charge. So what should happen? They should repel each other. Are you getting it? So it is not attraction, it is what? Repulsion. Why is it repulsion? Because they are what? Like charge. Are you getting it? Now the next one is now, so because they are like charge, they repel. To calculate the magnitude of the forces, you use Coulomb's law. But there's an issue because we do not know the distance between the two charges. So if we are to get the distance between the two charges, we are seeing something like a right angle triangle. So from a right angle triangle, we get the distance. Are you seeing it? Then we can now apply our Coulomb's law to get our answer. Actually, this is the answer. But the problem in this question is that they need that answer in coordinate system for both of the charges. So we'll now go, okay, because it's coordinate they want, right? For the 2 microcoulombs. You see it? If you have this force is behaving, if you bring it set, it's something like this, right? F is this. Basically, the most general method to do coordinates, I and J components, I represent X, J represents Y, is doing F cos theta, F sin theta. You get? But because now there is no theta, and it is true you can calculate theta, but it will take a little time. So you can just use that the force bracket movement in horizontal over total I plus the force movement in vertical over total J. And after doing that, you must understand that force is a vector. It also needs its direction. And if you look at this, the direction for here, it means horizontal is negative, vertical is what? Positive. So you put the sign. So after that, you do the same thing for the 3 Newton. So that's how it works. So let's take example 3. Let's read example 3. Calculate the net electric force exerted on a particle of this charge. So you want to calculate the force on this charge. due to the influence of these two charges. So it means these two charges are interacting with this and they are at a distance from it respectively, 20 and 50. So first thing you must understand is that you must be able to picture it, meaning you must be able to draw the diagram. And it's very simple. So how do you draw the diagram? From the question, I have a charge here, which is minus 4 microcoulombs, right? And I have another charge here, which is minus 3 microcoulomb. And from the question, the distance between these two is 20 centimeters. You should not forget. Exactly. Sorry, plus 5. Plus 5 is first, sorry. Plus 5 microcoulombs. And the distance is 20. Yeah, plus 5 first. So there's now another charge which is minus 3 microcoulomb, and the distance from this one to that particular one is 50 centimeters. So that's the diagram. Now, from your question, these two charges will interact with this. And I have told you when there are more than one charges interacting with another charge, you take them individually. Meaning we look at between the 4 and 5. Okay, let's just label them. Let's call this Q1, let's call this Q2, let's call this Q3. So we want to look at the force between 1 and 2. It becomes K, Q1, Q2 over R square, Coulomb's law, right? Just focus on these two, you get. So what is K? 9 times 10 raised to power 9 times what is Q1? I have told you the sign of the charge will not enter into the formula. So Q1 is what? 4 times 10 raised to power minus 6 times Q2 is what? 5 times 10 raised to power minus 6 over the distance between them is 20 centimeter, and this must be in meters. So convert centimeter to meter, you divide by 100. So when you divide 20 by 100, you should be getting 0.2 square. So when you press your calculator, you should be having 4.5 Newton. That's it. So that is this one. Do not forget again, there's a lot of things you should not forget. Charges, sorry, I said charges. Forces, they are vector, right? So if this is the magnitude, how do you get the direction? It is the type of charge that will show you the direction if it is attractive or repulsive. Now, from the sign, plus and minus, will it be an attractive force or a repulsive force? Definitely to be what? Attractive. It means attractive. F12, attract. F12, meaning they will attract each other. Are you saying it? Now, let's look at the next one. We are done with this 5 and this one. Let's look at how these 3 columns will interact with this, meaning how Q3 will interact with Q1. So the interaction between 1 and 3, according to Coulomb's law, your formula becomes K, Q1, Q2 over R squared. Is that not true? So what is K? K is 9 times 10 raised to power 9. What is Q1? Which is 4 times 10 raised to power minus 6. What is Q2? 3 times 10 raised to power minus 6. Over what's the distance between them? 50 centimeters. And do not forget, you must always convert centimeters to meters. Then you have what? 0.5 square. So if you do that, we should be having something like this. The magnitude. Now let's get the direction. Watch. Minus and minus. So they are like charges. So will they attract each other or will they repel each other? Definitely they will what? Repel. So if it is repulsion, I should have something like this. F13, F13. That's a repulsive force. But from our question, we are interested in the behavior of the forces in this charge. So focus your eye on these 4 microcoulombs. You are seeing that you have 2 forces, right? Moving in opposite direction. Are you seeing it? So to get the net, anytime you have 2 forces in opposite direction, how do you get the resultant of the net? You would subtract. Is it not true? 2 forces acting in the same direction, you would add. 2 forces in opposite direction, you subtract. two forces perpendicular to each other, what do? You use what? Pythagoras what? Theorem or trigonometric ratio. When two forces are acting at acute or obtuse angle to each other, you now do what is called parallelogram law of vector, or sometimes what we call cosine rule. Are you getting it? So now these two forces, they are opposite to each other. So how do you get the resultant? It becomes 4.5 minus 0.432. And you should be having something like 4.067 Newton. So that's how it works. So please, you must understand it. Now let's take the next one, example 4. Let's take example 4. I have three charges, Q1, Q2, Q3. Now notice all these things, they means location, meaning position. Exactly. So these things 0, 0 position, and you should be able to locate points in a Cartesian plane, in X and in your graph. You should be able to locate points. Oh, these are the charges. This is where they can be found, or this is where they are located. These zeros, this thing, they means location of the charge. So now let's see how our diagram will look like. So I have a Cartesian plane, something like this, Abby. Not true. Now I have Q1, which is this on the origin. You know, this thing means X is 0, Y is 0, and that's the origin. So I have Q1 here. This is Q1. So I have Q1 here. It's not true. I have Q2 when X is 0, Y is 10. So hope you can locate X0, Y10. There's something here. Okay, let's assume from here to here is 10. You get. So here is Q2. You saying it. And I have when X is 15, Y is 0. X15, Y. So how do you locate it? Okay, let's assume here is 15, Abi. So this become Q3. Exactly. So we can just assume here is 10. You get. Here is 10. So that's how to locate the three charge. Now the first question is, find the total electric force on the charge at this. So we want to look for the force on this charge, what? Q1. You get. So it means Q2 and Q3 will be interacting with Q1. So and you take the interaction individually. Are you seeing it? So let's look at the behavior between 1 and 2. You know, according to Columb's law, I have K, Q1, Q2 over R squared. Now, what is K? What is K? K is 9 times 10 raised to power 9 times what is Q1? The Q1 is what? 2 times 10 raised to power minus 6. Please don't forget the sign of the charge will not enter into the formula. What is Q2? Q2 is what? 4 times 10 raised to power minus 6 over what is the distance between Q1 and Q2? The distance between Q1 and Q2, it is 10, right? But remember, it is 10 centimeters. So you turn it to meter. So I have 0.1 square. How do I get 0.1? Change centimeter to meter. 10 centimeter. Change it to meter. You have what? 0.1, meaning divide by 100. So F12. When you press your calculator for this one, you should be getting 7.2. I guess so. Yeah, 7.2. Now, you will now check these two. That's the magnitude. Don't forget, force is also is a vector, so it will have direction. We will now check, is it attractive or repulsive? But let's check that out. Q1 is negative, so it's negative. Q2 is positive. Negative and positive, unlike charges, what will happen? They will attract. So I have an attractive force like this, right? Here, they attract each other. F12, F12. So it is an attractive force. Now let's look at the behavior between 1 and 3. According to Coulomb's law, K, Q1, Q3 over R squared. So what is K? K is actually 9 times 10 raised to power 9 times what is Q1? Q1 is 2 times 10 raised to power minus 6. What is Q3? Q3 is what? 3 times 10 raised to power minus 6 all over. The distance is 15 centimeter to meter. Don't forget. You come out centimeter to meter, you should be having 0.15 square. And the answer should be 2.4 Newton. Also, don't forget direction, right? So Q1 and Q3, check. Q1 is negative, Q3 is negative. Negative and negative, what will happen? They repel, right? So these two will repel each other. So I have F13, I have F13. Now, if I want to write the force, the total force on Q1, right? Remember, vertical is I, sorry, vertical is J, horizontal is I, right? So the horizontal, which is F13, right? The value is 2.4 I plus vertical is what? 7.2 J. You know, vertical 2.4, horizontal this. But do not forget direction, right? This part on your graph is minus x. This part of the graph is plus y. It means horizontal will take what? Negative. Vertical will take what? Positive. So this is the resultant force. This is the force. So from there you can get the magnitude. As I find the magnitude, so how do you find the magnitude for something like this? It is square root, right? Or minus 2.4 square plus what? 7.2 square. So if you do that, you should be having 7.6. Should having 7.6 approximately. That's the magnitude. Now they ask for the direction. You know, direction is theta is equals to tan inverse. The movement in vertical 7.2 over horizontal. Hope you know vertical over horizontal. So I should be having 71 point, I think 4 or 6 degrees. Now, but what you have just done is that from here, means something like this. This is your resultant. And the angle you're always calculating, which is theta, is always to the horizontal. You see it? But you are asked to calculate the angle from the positive x-axis. It means this theta is actually 71.6. But you want to know from positive x-axis, anti-clockwise direction to the vector. Don't forget, the sum of angle in a straight line is what? 180. So if this part is already 71.6, then what will be this part? So it means your original direction will be what? 180 minus 71.6, which is 10, I think 8.4 degrees. That's how it works. Or you can use your quadrant. Yeah, theta is theta. Yeah, the final answer is 180 minus theta. Here is what? Theta plus 180. Here it is 360 minus theta. You can also use your quadrant to get the final answer. Or you can just think like, so angle in a straight line 180. So if here is already 71.6, then what will be F to here? 180 minus 71.6. So that's how it works. All right, so let's take this example. Two tiny balls, each of mass this, are suspended from a common point. Two tiny balls, don't forget their mass. This is 1.52 milligram. Are suspended from a common point by a light insulating thread. So the light insulating thread is this long. If they are assumed to be point charges, so they are point charges of equal value. So their values are the same. Now repel. So they repel each other until each make an angle of 15 degrees with the vertical. Calculate the charge on each ball. One of the skills you must possess as a science student is the ability to interpret and the ability to imagine. So you should be able to imagine this question, meaning you should be able to draw the correct diagram from this question. Most of the time, if you cannot get the correct diagram, it's almost impossible to be able to solve it. You see it? Right, now let's get the diagram. Let's get the diagram. Now to get the diagram for this, now let's start. Two tiny balls, each of this mass, are suspended from a common point. So you have a common point, you have two tiny balls, something like this. So you have two balls, and the thread, you are given that the thread is 20 centimeter long, right? Now they are assumed to be point charges of equal value. So don't forget the charges are of equal value. And they repel each other, until each make an angle of 15 degrees. So I have something like this. Now. They now keep repelling each other. So I have something like this. Are you seeing it? In which The force of repulsion F F until the angle with the vertical, each of them is 15 degrees. Each of them is 15 degrees. Don't forget, they will have, because they have mass, so they will have weight. They will have weight as well. You get, and don't forget that the length of this thread is 20 centimeter. 20 centimeter. Now, because this is thread, you will have done forces, right? So thread has what is called tension. String has what is called tension. So this string we have a tension T. We have tension T. Now, they ask us to calculate the charge on each ball. First of all, according to Coulomb's law, forget this rubbish first that's on the board. According to Coulomb's law, what you know that F is equals to K Q1 Q2 over R squared. But Q1 and Q2 are the same because they are identical charge, right? And of equal value. So I have F is equals to KQ squared, the same, right? Over R squared. So if I make Q subject to formula, Q becomes FR squared over K, then the square root. It means that to get Q, you must know what first? The force, and you must know the distance. Now, from your diagram or from your question, do you know the force? No. Do you know the distance between the two charge? No. So our goal is to get force and distance first before getting Q. In getting the force and the distance, that's when you must have a solid understanding about resolving forces and geometry. Now, let's get distance. How do you get the distance between these 2 points? If you look at this very well, it's looking like a triangle, right? So you have a triangle like this. You are seeing a triangle like this. A triangle like this, where here is R, and here is 20 centimeter, here is 20 centimeter. Is that not true? Now watch. Hope you have not forgotten what is called alternate angle, right? So if here is 15, if you break here down, what do you have? Alternate angle, which has Z angle. Now the angle here is equal to the angle here, right? So alternate angle are what? Equal. So if here is 15, definitely here will be 15. Similarly, there's an alternate angle here again. Here also will be 15. So the total angle here will actually be what? 30 degrees. Meaning, see, it's alternate angle. So here is 15, here is also is 15. So the total for this full side will be 30. Seeing it? If you look at that triangle, remember, when you were doing mathematics in basic level, you were taught Pythagoras theorem and trigonometric ratio. And you were told clearly that you use Pythagoras theorem and trigonometric ratio if the triangle is a right angle triangle. You see it? But if the triangle is not a right angle triangle, you now start using sine rule and what? Cosine rule. So if you look at this, you will notice that this triangle is not right angle. So because it is not right angle, we are not going to use what? Sine rule or cosine rule. But the most relevant based on this parameter is what? Cosine rule. We all know what cosine rule, which is a square is equals to b square plus c square minus 2bc cos theta. So let's apply it here. R square is equals to 20 square plus 20 square minus 2 times 20 times 20 cos 30. So R square, I think this will give you 400 plus 400 minus 697.2. That's a lie. Let's check. Let's check. So 20 times 20 times 2 times cos 30. Okay, 692.8. So I have 692.8. You get. So R square is equals to, this is 800 minus that. So we should be having square root of 107.2. So if I take the square root of that, I should be having 10.35 centimeter. So that's how it works. So if that is true, now okay, take the square root. R is equals to 10.35 centimeter. So that's R. So you can convert it to meter, right? Which is 0.1035 meters. So if you have gotten R now, first problem has, now let's get the second one. If you look at this, you are seeing something like a force, right? Like a force system, something like this. Where here is F, here is T, here is W, and an angle here of what? 15 degrees. Is it not true? Now, how do you now resolve something like this? You must have a solid knowledge in resolving force, especially what you did in equilibrium of forces. In equilibrium of forces, you can use different method. You can use Lami's theorem. You can use resultant rule. Yes. You can use triangle of forces. You get. I think there's one, and you can use resultant method. But for me, the one I prefer is triangle of force because it's very simple. Triangle of force just tell you that the three forces can be represented with the three sides of the triangle in magnitude and direction. How do you forget that big English? How do you get it? Just extend any force. Anyone you want to do, extend it and translate one. Let me explain. This T, extend it. You can extend anyone. Oh. So this T, right? This is the extension of T. Then translate this F from here to here. That be something like this. I extended T and I translated F. So I'm saying something like a triangle, which is something like this, Abi, which is T that I extended, my F that I translated, and the one that remains the same there, which is what? W. Saying it. Make sure the angle is put correctly. This angle here is between T and vertical. T and vertical. This is T and this is vertical. This is T, this is vertical. So the angle is here, 15 degrees. Now you can now solve it using Pythagoras theorem, you get. But first of all, let's get W. You know W is equals to mg. And your mass from your question is 1.52 milligram. Do not forget, for you to multiply mass and G, mass must be in kilogram. So you have to find a way to convert this to kilogram. Do not forget that milli means times 10 raised to the power minus 3 gram. Hope you know. Then the next one, how do you convert gram to kilogram? Divide by 1000, right? So it should be 1.52 times 10 raised to the power minus 6 kilogram. So from there, to get weight, you have mg, and the mass is 1.52 times 10 raised to the power minus 6. And g from your question, take the one from your question, 9.8. So let's press our calculator. So 1.52 times 10 raised to the power minus 6 times 9.8. So I should be having 1.4896 times 10 raised to the power minus 5 Newton. That's W. Now, if I look at this one, we can easily solve the right angle triangle, Abi, where this is hypotenuse. Is it not true? Here is opposite, and here is what? Adjacent. And our focus is on W, which we have, and F, which we are looking for. Adjacent and hypotenuse. So between SOHCAHTOA, which one has adjacent and adjacent and opposite, adjacent and opposite. In SOHCAHTOA, which one have adjacent and opposite? You know it is TOA. So I have tan theta, which is 15, is equals to adjacent W. You know your W is 1.48. No, sorry. Tan theta is opposite, which is F, over adjacent, which is 1.4896 times 10 raised to the power minus 5. So cross multiply. F becomes, so if you multiply that, I have that 1.4896 times 10 raised to the power minus 5. Then I have times tan 15. So I have 3.99 times 10 raised to the power minus 6 Newton as F. So if that is true as F, so can we now get Q? Now we know R, this is RB, and we know that this is F. So can we get Q? It's not very much easy to get Q, right? So we can get Q. So how do you get Q now? Let's use the up. So how do we get Q? Q now becomes from this formula root. What is your F? 0.99 times 10 raised to the power minus 5 times what's your R? 0.1035 square over what's Q? 9 times 10 raised to the power 9. So Q becomes, this is minus 6. So I'm having 2.17 times 10 raised to the power minus 9 coulombs. But you want to write it beautifully, 2.17 nano. Hope you use nano coulombs. So that's it. So charge is 3q at the distance 2a along y-axis and minus q at the distance a on the positive x-axis. Find the force of attraction between the 2-point charges. Alright, so I want to do this. Now, you should be able to interpret. Is that clear? So how do you interpret? Two charges, 3q at a distance 2a along y-axis. So you have a coordinate system, Abi. Something is at 2a. This is 3q. So the distance here is 2a, right? From here to here. That gap is 2a along y-axis. And minus q at a distance a on the positive x-axis. So I have a, this distance from here to here, let's say a, and the charge here is what? Q, minus q. Then ask me, find the force of attraction. Okay, you know that according to Coulomb's law, F should be K Q1 Q2 over R squared. Is that not true? But I know K, I know Q1, I know Q2. The issue is that the distance between this one is not the main issue, Abi. The distance between them are. Now, if I look at this is looking like a right angle triangle. Is that not true? So, which I have something like this, wherein here is what R, here is what A, and here is what 2A. Is that true? So, can I get R? Yeah, the R is root Abi 2A all squared plus A squared. Now, let me use R squared, like square both. R squared becomes, this is 4A squared plus A squared. So R squared is 5A squared. Do you know I'm using R squared? Because what I need to use here is what? R squared. So we'll just pick 5A squared. You see it? So now, let's go. F become K remains K. Q1 is 3Q. Times Q2 is Q. Remove the sign, don't forget. Over R squared is 5A squared. Don't do 5A squared. R squared is already 5A squared. So I have 5A squared. So what I have? F is equals to, then I have 3KQ squared over 5A squared. So F 3 divided by 5 is 0.6 KQ over A squared. So is it option A? No. No. Yes. So the correct option is what? C. So that is actually Coulomb's or electrostatics. So in the next chapter, we are doing electric field. So don't miss. So what must you have in mind? First of all, the study of the interaction between charges at rest is called what? Electrostatics. Is that true? There are two kinds of charge, positive and negative. And both of them are created as a result of the electron. When there is deficiency in electron, you have positive charge. And when there is surplus electron, you have negative charge. Charges can be created in three ways: by contact, by friction, and by induction. And an instrument to measure or detect small electric charge is called what? Electroscope. Is that true? And you must understand the principle of charge conservation and the principle of charge quantization. That the charge before reaction should be equal to the charge after reaction, or the algebraic sum of the total charge in an isolated system must be what? 0. You must also understand from the principle of charge quantization that the charge on an isolated body Q is equals to the integer multiple n of the charge of the word electron. And you must also understand Coulomb's law. What is Coulomb's law? Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the charge and inversely proportional to the square of their distances apart. Yeah. So do have a nice day and God bless you. See you in part 2.